The greatest mistake modern farming makes with floodwater is trying to make it behave like dry land. Once that mistake is made, everything else becomes expensive. The water is treated as a threat to be removed, the mud as a burden to be stabilized, the basin as a problem to be simplified, and the entire landscape is forced toward a single output that can only survive if enough labor, enough luck, and enough control are constantly applied. But ancient monsoon civilizations did not always begin with that assumption. Some of them asked a harder and smarter question. If water is going to move every year anyway, what kind of food system becomes stronger because of that movement? That question leads directly into the logic of the lost Khmer wetland engine. Not one crop, not one pond, not one field. A layered floodplain design where climbing perch, lotus, and flood rice occupied different hydrological zones of the same seasonal basin. The genius is not just that each one produces food. The genius is that each one solves a weakness in the landscape and in the others. The first problem in a monsoon floodplain is instability. Water rises too high, spreads too wide, lingers in some places, retreats too fast in others, and turns the same ground into different environments within the same season. If you try to force every square of that world into one single crop, then every variation becomes a risk. Some parts drown, some dry too early, some overheat, some lose oxygen, some trap too much debris. The Khmer solution was not to erase variation, it was to assign a role to variation. The slightly raised bands and shelves became the rice layer. This mattered because rice needed access to the annual abundance of water without being buried under the deepest hold of it. Too low, and the roots would sit too long in damaging flood. Too high, and the crop would miss the moisture pulse and fertility that made the floodplain worth farming at all. By lifting the rice just enough above the deepest flood hold, the system solved the central problem of monsoon agriculture. It gave grain a stable spine without removing it from the living wetland below. The deeper and calmer pockets became the lotus layer. This solved another problem. Open floodwater is often too exposed, too hot, too visually bright, and too unstable as a biological space. Left naked, it can become more violent in temperature and less efficient at holding edible life. Lotus changes that. It shades the basin, cools the surface below its canopy, breaks glare, slows microcurrents, and creates a calmer underworld where drifting matter, small life, and rooted food storage can all build up together. It also produces one of the most powerful wetland food forms in any ancient system, buried edible mass. Rhizomes and black silt, seeds above water, stems and tissues with multiple uses. In other words, lotus turns exposed water into stored calories. Then comes the climbing perch. This is where the wetland engine stops looking like agriculture with extras and begins looking like a complete food machine. The perch solves the protein problem in a floodplain where raising conventional livestock would be more expensive, more fragile, and often less suited to fluctuating wet conditions. It thrives in warm, shallow, changing water. It uses channels, root shadows, shrinking pockets, and refuge holes. It feeds on the wetland's small life, insects, larvae, detritus, and organic abundance. That means the system does not need to purchase or import a separate protein chain into the field. The floodplain itself grows the base of the food web, and the perch concentrates it into flesh. That is the heart of the solution. The landscape first produces diffuse biological abundance. Then the fish layer gathers that abundance into edible protein. The workers do not have to invent every calorie from scratch. They shape the field so the field begins producing edible relationships on its own. The channels and refuge pits are what make that possible across the full season. During the early flood expansion, fish can spread, feed, and move through a larger world. During retreat, that same mobility becomes an advantage for the humans because movement narrows into predictable routes. Channels guide fish, pits hold them, basin edges concentrate them. What was once dispersed becomes collectible. This solves a major ancient food problem, not only how to grow protein, but how to make it harvestable at the right moment. The lotus layer supports that process indirectly, but powerfully. Its shade lowers stress in deeper holding pockets. Its stems and roots create structure and shelter. Its canopy creates zones where smaller aquatic life survives more densely. It is not fish feed in the crude modern sense, it is habitat architecture. And habitat architecture is often more valuable than direct feed because it keeps the entire wetland biologically productive without converting the system into a simple input-output machine. The rice layer solves a different problem that no fish-rich wetland alone can solve. Protein helps survival. But civilizations are not built on protein alone, they are built on stored starch. Rice is the dry promise carried out of the wet season. It is what can be cut, dried, stored, moved, taxed, traded, and rationed. In a true monsoon civilization, the perfect system is not the one that chooses between fish or grain. It is the one that makes both possible inside the same water logic. That is why this engine matters so much. It does not ask the floodplain to choose one identity. It lets the same seasonal basin produce concentrated protein below, edible root mass in the middle, and stored grain on the lift. This layered arrangement also spreads risk. If the rice suffers in one part of the basin, the lotus pockets may still hold reserves and the fish lanes may still produce protein. If one deeper area silts too quickly, a different refuge hole may still carry the fish layer through retreat. If exposed water overheats, lotus cover can protect the biologically richer zones. If flood timing shifts, the system still does not fail in one single stroke because its outputs are not all tied to one exact depth, one exact temperature, or one exact growth zone. That is one of the great strengths of ancient ecological intelligence. It does not promise perfection. It prevents synchronized collapse. This is why the water retreat phase is so important. Modern people often imagine abundance as the moment when there is the most water. Ancient flood systems understood that abundance becomes truly useful when water begins to contract. As the basin shrinks, fish routes narrow, holding pits deepen by comparison. Lotus basins become more accessible for root harvest. Rice rises visually above the lowering edge and moves toward grain maturity. Retreat is not the end of productivity. Retreat is the concentration of it. That insight is one of the clearest markers of a civilization that truly understood monsoon hydrology. And because food emerges in layers and at different moments, the system creates continuity instead of one desperate waiting period. Early in the season, the basin is mostly investment and structure. In the middle season, the lotus canopy and fish web deepen. By late season, the field begins to return grain, roots, and concentrated fish from the same designed landscape. That means the household or community is not forced to depend on one event alone. It moves through a sequence of edible returns. Even the labor logic becomes more efficient because each action serves several purposes at once. Maintaining a ridge protects grain but also preserves the channel edge below it. Managing a deeper lotus basin keeps root production alive while also maintaining cooler fish refuge nearby. Preserving a connecting cut allows basin movement while also setting up future fish concentration at retreat. In other words, the workers are not maintaining three separate farms. They are maintaining one wetland body with three major food organs. The engine also explains why ancient flood civilizations could support density in places that look unstable to outsiders. Outsiders often see mud, standing water, heat, insects, and shifting edges and assume the place is too chaotic to be truly productive. But the truth is often the opposite. Some of the richest human landscapes are rich precisely because they contain several levels of moisture, several speeds of water, and several layers of food at once. The challenge is not whether such a place can feed people. The challenge is whether the people have learned how to read it well enough. That reading is the hidden technology of the whole system. The workers do not simply plant rice, pull lotus, and catch fish. They observe contour, seepage, depth, temperature, flow, stem density, and the timing of retreat. They know which ridge can still hold rice, which basin still hides roots worth lifting, which fish path is active, which refuge pocket will carry protein deepest into the dry down. The intelligence of the system lives not only in its structure, but in the bodies that interpret it. And that may be the deepest lesson of the lost Khmer wetland engine. It is not merely a triad of foods. It is a complete answer to a difficult landscape. The floodplain gives instability. The civilization answers with layered hydrology. The heat threatens exposed water. The civilization answers with lotus architecture. The need for storage demands grain. The civilization answers with lifted rice backs. The need for protein demands something the wetland can naturally support. The civilization answers with climbing perch. One problem, 3 layers, one seasonal machine. So when we look at a basin of flood rice, lotus, and dark fish channels, we should not imagine 3 disconnected harvests sharing the same scenery. We should see a single engine solving several ancient problems at once. How to store calories, how to produce protein without external feed, how to keep water useful rather than destructive, how to survive variable flood, how to turn retreat into harvest, how to make the same landscape feed people more than once in more than one form. Once you see that clearly, the lost Khmer wetland engine stops looking picturesque and starts looking profound. Not a swamp with food in it, but a civilization that learned how to make water think in layers.